um, they give us like one whole bunch of like numbers, and then they ask us to actually uh, achieve order structure, order property. That's what we are trying to actually achieve. So we have all the numbers. Then because like these guys, they don't have children at the start, so we can actually ignore them. And fundamentally, it's usually half of it, right? Because of math. So what you're gonna do is that you have a 9, you divide by 2, you round up, you round down, you go to the fourth index. So that's this guy is technically the guy that most likely I think in terms of math is gonna have children, right? So now, and when you see about like this guy, I feel like this is 1 2 3, and then this is the fourth guy, and fourth guy usually have children, which is true. So you're gonna start comparing from this guy onwards. So what's gonna happen is that you're gonna ask the question, um, operation Z, where is um, left and right got children or not. And like fundamentally we say that left side and right side um, have children, and then and that operation Y is actually asking, is my root like more than, is it like more than my children? So I think maybe operation Y may be asked first, if my root is like more than children or not, and then we see like, okay, which guy is like a suitable guy for me to actually bring it up. So operation X is like between the left child and the right child, which one is like the uh, which one is like the smallest, or rather which one is the minimum. Alright, which guy is the smaller, then I will perform a swap. And obviously there's like nothing to do actually to do a swap over here, so nothing does actually happen. So then down we come to maybe say this 40, and then there's maybe say a 20 over here. We similarly do the operation Z, Y, X. So ask my root, is it like more than is it like less than our children? And it is, therefore we perform, is there left and right children? There is. Between the left and right, which one's smaller? 20. So I do a swap, 20, and then 40 over here. So we perform a swap. And now we come over to here. There's originally an 80. Yeah, I don't know, maybe this guy is like a 30. This guy may be a 10. So I do the operations. Is by root smaller than say my children? Yeah, it's cool. So we come to here. So I think originally this guy is like maybe say um, a 50. So do I have like left right children? So I should really say that which guy is actually smaller. I mean, um, I asked the question over here first. Maybe 10 and 30, which one is smaller? I mean, 10 is definitely smaller. So I do perform a swap. 10 over here, 80 over here. Between these two, which one is smaller? 10 is smaller. So I perform a swap. So between these two, which one is smaller? I mean, 30 is smaller. So yeah, like pretty much this is this. So whatever we have done, like sidetrack a little bit, is that we are thrown in with like a bunch of numbers, and we want to actually throw it into like following the rules of like a heap, or say like a priority queue. This is how we actually do it under the hood, where we just been thrown with all this bunch of numbers, and then we just sort them accordingly with all these rules. So these items, yeah. And on a sidetrack a little bit again, is that all these items that we've been explaining is like under the hood, in the code, under the hood of like the code, under the hood of like the algorithms, on how actually heap and priority queue actually do fundamentally work. And so when we actually been thrown into like a say like a leak code question or what not have you, we are just bringing out this character in, but under the hood, what's actually going on? It's all these items. And I'm just curious on how this character is gonna actually play out in the leak code question problems. I'm just very much curious, very much curious on how these guys is gonna be on like the playing field in the leak code problems. So with that, everything comes to an end.